Greetings from Bulgaria, I am Anton, and in this tutorial we'll talk about checkboxes. Yeah, I know, we don't think about them all the time, but they're everywhere. Do you want to be walked in every time or answer to a multiple choice question? We use them to mark that we want to reuse the information between payments in an online shopping cart. It's a technique to turn things on and off while also allowing multi-selection. So checkboxes have a wide implementation in web pages and help users to give consent, toggle, or select multiple choices as required in various applications. So in this video, you're going to learn how to handle various variations of widely used web components, the checkbox. So we're going to talk about what is the checkbox, many of its attributes in HTML, why they are important in our automated tests, and of course how to check and verify its content. Of course, we're going to see many demos with single checkbox, multiple checkboxes, even commercial off-the-shelf components that use checkboxes like tree list views, and we're going to automate them in different ways. And of course, as part of this job is how to locate the checkboxes the right way. So I'm going to show you some different strategies using complex XPaths or using the new Selenium 4 relative locators. If you haven't subscribed for the channel, please do so, hit the ring bell so that you get notified about the new awesome videos that are published each week to the channel. In the links below, you will find a link to the GitHub repo, and then you can download it and play with it. What more? If you have any comments, put them in the comment section below. So let's get started. Let's talk about checkboxes. The first place to visit is this MDN documentation, web docs about checkboxes. There we can find information what are the checkboxes. And let's discuss now all of their different attributes. So the checkbox in general is a UI element component on any web page that facilitates users to make choices, right? From the given set of options, once the choice is made, it helps to record any further processing. During our demos, we're going to use again the LambdaTest playground, and here this is a simple checkbox, right? We checked it. Or this is multiple checkbox, where we can check all of the options. And here on the MDN website, many of the attributes of this HTML component are described. When it's selected, it's termed as checked. When it's deselected, it's termed as unchecked. So the checkbox can allow the user to make single choice from a list of options, multiple choice as you saw in the example, give consent, or toggle on and off for certain requirements on a web page. It's interesting to note that some applications also provide an indeterminate state, also called tree state, where instead of a tick mark, which is the usual representation of a checkbox, a field, box, or a dash is used to dedicate the selection. For example, here, let me find. Here in this article on the LambdaTest blog, how to select checkboxes, there is a picture of it. This is this state that I'm referring to, intermediate, where you have child checkboxes, and basically child boxes, when a child box is selected, that makes an auto selection for all parent checkboxes in the hierarchy. And checkboxes are majority used on web pages to offer multi-choice to a user. On an HTML page, this can be identified with several unique properties to automate checkboxes. By the way, here, if all of these checkboxes are checked, then the parent checkbox is checked as well. Otherwise, if all of them are unchecked, this is unchecked. If half of them are checked and unchecked, then you have this slash or a dot. It depends really on the implementation. Right here, as you can see, since we have many childs that are unselected, we have the dot or this particular state. So a checkbox is a DOM. In DOM is defined using the input tag, which is of type checkbox. Usually we have ID or class or name. Also, this checked attribute is a Boolean attribute indicating whether this checkbox is checked by default when the page loads. It does not indicate whether this checkbox is currently checked or unchecked. And if the checkbox state is changed, this content attribute does not reflect the change. Also, we have sometimes value attribute here. This value attribute is a string representing the value of the checkbox. This is not displayed on the client side, but on the server. This is the value given to the data submitted with the checkbox name. The value attribute is one which all inputs share, because we have input button and input text and many others. However, it serves a special purpose for inputs of type checkbox. When a form is submitted, only checkboxes which are currently checked are submitted to the server, and the reported value is the value of the value attribute. So, in addition to checked and unchecked, there is again this third state. Usually, if we scroll down, you will find information about it. This this third state can be basically configured through JavaScript. There isn't an attribute about it. What else? Also, we have for validations, we have basically a required attribute, which when the form is submitted, it will pop up a validation if this is present. Also, we have the disabled attribute if you don't want to be checked based on other validations as well. So, what else? Let's directly start with our demos. And to automate checkboxes, first let's start with something simple. Again, we are going to use the LambdaTest Selenium Playground. I suggest you to check the website. It's really awesome. It has many different examples, and you can test your Selenium knowledge. So in the section about checkbox demo, we have two basic examples. First, a single checkbox here. If we inspect it, we'll find out that this is input type of checkbox. We can find it by ID, and then we are going to click it. And then in Selenium, I'm going to show you how we can verify whether it's checked, it's selected, or disabled. And then our second test will be about, as you can see here, we have multiple divs containing multiple checkboxes. Maybe the shared thing about them is that we can find them, all of them, using find elements by their class, or we can use unique XPath. For example, let's write it like this. We want input. Let's copy just the ID. As you can see, they share identical ID, just the number is increased there, right? So we can find them like this. We can say, please, the type should be checkbox. And as you know, in XPath, we can chain multiple conditions using the AND keyword. And we can use special methods, for example, contains, or in our case, we need starts with, and we can provide any attribute. In this case, with add, I will refer to the ID, and then I can link. As you can see here, we found 4 of them. So this is the locator that we are going to use. Then we can for each them, we can click them, and then I'm going to show you another way how we can verify them. A little bit about the project. Here, this is a standard Selenium setup for Java. I use JUnit together with Maven and Selenium. If you're not familiar with Maven or JUnit, I suggest you to check on the LambdaTest channel. There is a whole section of videos regarding JUnit setup that I recorded, and they're basically in the POM XML. I installed all of the required and necessary JUnit dependencies, the required dependency for WebDriver, and I installed WebDriver Manager. Then we have a standard JUnit class where I have a reference to the Chrome driver. Before all of the tests, I'm using WebDriver Manager to download the correct version of the Chrome driver based on the version that you have installed on your machine. And then before each test, we are starting the Chrome driver, we maximized it. And then later in our test, we are going to use WebDriver wait, as you know, to wait for particular conditions. For example, for element to be present or to be clickable. That's all. And then we have standard Selenium Java tests. Let's follow the Java formatting, right? So, what else? After all of the tests, we're shutting down the browser. That's everything about this project. As I said, in the links below, you can download the full source code. You can find it in GitHub. So, let's get started. First, we're going to, for the first simple demo, we are navigating to the LambdaTest Selenium Playground. Then, in order to find the first checkbox, again, we are using find element by ID. I showed you the ID there. We can use the JUnit assertions to check whether the checkbox is visible or not using 𝑨𝒏𝒕𝒐𝒏 method. And of course, in order to check it, we use the click method. This will select the checkbox. After that, in order to check whether the checkbox is enabled or not, whether it's clickable or not, we can call the method isEnabled to check that it's enabled, not disabled by some validation. And to verify that we checked it, we use isSelected method. If at some point what else? For the second example, we again navigate to the website, and then now is a tricky part. As I explained, we can use the class to find all of the checkboxes. Please pay special attention that this time I'm using find elements here by class name, or I can use the XPath, that I showed you before with starts with. Here, type checkbox, starts with ID, things that I showed you. And after that, we can use for or for each to iterate and check all the checkboxes that we found. You can, of course, use again for each. It doesn't matter whether it's for or for each. If you use for, then you will be required to get the current element from the list using the get method, passing the current index. Here I'm making sure that the checkbox that before clicking it is basically displayed and enabled, and just after that we're clicking it. Another way, shorter maybe way, to handle that instead of writing this for whoops, is to use stream API and use for each, and then use a lambda expression. C stands for checkbox, and then here we can create multi-line multi-line lambda, and instead of using the index, I can change it with the current checkbox C. We can even make it even shorter, removing these brackets here, like this. In a similar fashion, we can click just a single of these elements. Here we are checking the second checkbox from the list, and of course, in a similar fashion, when we have multiple of them, we can get it by index, and then we can check whether it's selected or not. What else? In some rare cases, if we return to the examples, we'll have tables like this, where you have checkboxes here. And many often the data inside these tables is dynamic, so we want to be able to find this information here, and by it find the checkbox related to it and then click it. In order to do so, we'll have to write maybe a complex XPath, or let's first explain how to do that with complex XPath. First, we'll have to find this span, then we'll have to find each H4, then we'll have to select its parent div, then its parent table row, and then inside the first table row here, we'll have to click the input or the div, probably the div, because sometimes when there is such wrapping, if you try directly to click the input, probably it will fail. So let's try to write this type of selector. First we write span contains text green, which as you can see we find this particular part. Then we'll use XPath access, where we're going to say please find me its parent, which is H4. Then we need to find 2 times the parent divs. Again, parent div, parent div. Then we need to find the parent table row, parent table row, and then since they're on the same, because basically this is not a parent, but it's preceding sibling, so we need to use preceding sibling div. And this is the checkbox here. As you can see, it's relatively complex locator. However, you can use string format and just provide the text, dynamic text here, and find checkboxes by text. So here in this particular test here, we can find it, the checkbox, by this locator that I mentioned, right? It's really long, but again, you can abstract in a private method, and here in the string format we can provide this as an argument, this particular text. However, there is a second way if we use Selenium relative locators. If you are not aware what is this, please check my Selenium for relative locators video in the LambdaTest channel. But basically it allows us first to find this span here, and then using the relative locators we can instruct Selenium to find the first div that it's left of this particular span, and this will make our code much more readable and short. So let's define this second way of handling this complex scenario. Second way. So first we are going to find the span that I showed you by text green. Again, you can make this a private method and find this by any text there. And then this is the syntax for relative locators. driver find, we use the special with method, and then we provide that we need to find a diff. This is basically the diff here, that it's to left of the text column that we found before. Again, these two lines will do the same as this complex locator. It's up to you which of these two you're going to use. This is more optimal because you're going to make just one call to the WebDriver server, but anyways, it's a matter of choice. Then, again, you use normal click method to check it, and again, we can assert it like before, whether this is enabled or selected. But I really like derivative locators because in these complex cases, they really help. In some cases, if you watch some of my other videos about Selenium 4 on the LambdaTest channel, you are familiar that I'm really a fan of this to-do application MVC website, which basically holds implementations of this to-do application written in React, jQuery, and many other technologies. But the whole deal here is that it's a simple to-do application written in different technologies, like, for example, milk, coffee, more milk. And how this works is that if we open here application tab, you'll see that in the local storage, we have keys here. This is basically the ID of the item, which basically is the name of the application and some unique GUID. And then we have basically in the form of a JSON, the content of the to-do items. In certain cases, when you interact with these dynamic tables or applications, you would want to create your own data and find it later using this with relative locators or with this technology with the XPath access. So let me show you just really quick how actually this works. We can clear the local storage with JavaScript like this. Then with JavaScript we can reload the web page. As you can see, we deleted all of the items. We can create a new item like this. Basically, I'm creating anonymous object here, JavaScript object, with random title, with random date and order. Then we need to add this to the local storage. And we need, again, to add the particular ID in the right way. And after we refresh, you will see that we have this random value. In order to check it, we can, as you can see, first is the label, then it's the input. Of course, you can use the relative locators to do that. However, in this case, I even wrote it here. The locator here is relatively simple. We find first the label by text, but it's text. Since you created it, you know what is the text. And then we use preceding sibling, which is the element on top, that it's a type of input, and then we can check it. As simple as that. So the last example that we are going to discuss today is a little bit more complex. There are some commercial off-the-shelf components. This is just one example. I don't have any relation with this project. I just searched for it just to for the examples. I haven't used them, but basically these components, they allow you to not write these components yourself, but you can reuse them and use them in your application. So as you can see, we can click on the separate folders. We can check multiple folders. You see this third state of the checkbox. And in our test, the thing that we want to do is that by this label, we want to check the checkbox. And the second thing that we want to do is to be able to toggle on and off expand the different folders. The way we can find them is relatively simple. Again, we'll load this particular web page, and then if we inspect, as you can see here, we have the span and then we have the checkbox, so it will be relatively simple to find them. Here is the folder, and then I'm going to say with relative locator find me the div that it's left of this span. So I'm going to find this particular span by label, text contains or equal, as you wish. Then we are going to check it. In order to find this particular unique arrow, expand arrow icon, triangle, we are going to search it by class name. And again, we are going to use relative locators, relative from the checkbox itself. And when you use 𝑥𝒏𝒕𝒐𝒏 to find relative locators like this, since there are many options, there are many triangles, we need to use dot syntax, which means we use dot when, for example, you are searching for, you found a div or a table and you want to search inside of it instead of in the whole page. Then you need to provide the dot and instruct WebDriver that you want to search inside this particular element. So relative locators are working in a similar manner, and when you use 𝑥𝒏𝒕𝒐𝒏, don't forget to put dot when you use 𝑥𝒏𝒕. So this way we are going to automate that. And lastly, we'll finish with a method where I'm going to provide as a list names of the folders that we want to expand, and a list of the checkboxes that we want to check, because in many often we want to reuse the code and make it more abstract. So let's see it in action. First, we open the Treeview, and as I said, we first find the span. Basically, this is the label of this particular folder, and then in order to find its checkbox, we use relative locators. Checkbox driver find element with tag name div. This is the checkbox near the label, to left of the checkbox label. Again, you can make a private method and provide this folder to as an argument and use string format to create the proper attribute. And then in order to find the section, this is the way to do it. We can use this complex 𝑥𝒏𝒕𝒐𝒏 locator, or we can use relative locators again, as I explained before, like this. Basically, we're saying driver find element with by 𝑥𝒏𝒕𝒐𝒏, and here I use the class, but again with dot, to left of the checkbox, and this works just fine. And of course, we can click and open the section and verify that the checkbox is checked, enabled, or disabled. For the second method that I mentioned, that we want to make and reuse the code, we can first, for each, as you can see, we provide two lists of strings. The first are the names of the sections to be expanded, and then the name of the checkboxes to be checked. So first, again, here I did what I told you to do. Basically, here I use string format to basically find the correct span, the label, and then we wait for it to be clickable, and then we click it, since if you want to expand something that is inside another node, we want the element to be clickable, and then we click it. And after that, if we want to check the checkboxes, Here we iterate, but you need to be careful. If it's not unique, you have to wait for that. So we again use string format to create the right 𝐂𝐡𝐚𝐫𝐬 for the current node to be clicked. We wait for the checkbox to be clickable if it's inside another node, and then we click it. That's it. And then later we can reuse this method in many places where we put this commercial off-the-shelf control for Treeview checkboxes. Awesome, right? So thank you for watching. I hope that this video was useful to you. If you have any comments, put them in the comment section below. I will be really happy to hear your thoughts, and if you have any recommendation about future videos, please suggest. Also, don't forget to download the full source code and check the resources below. Don't forget to check the LambdaTest blog for many awesome articles and the community website for any help. You can learn a lot from the blog. And don't forget to get your free LambdaTest certification about Selenium, JUnit and many other technologies. See you soon, stay safe.